Okay, I want to find another way to look at solutions to a differential equation. And I bet we still don't know what a differential equation is.
Equation involving derivatives, the solution is a function.
An equation involving derivatives whose solution is a function. Could be a relation, actually, but so close enough. In other words, it's not a number. Okay, so first we had qualitative characteristics. We looked at the derivative, and we could make some comments about the function. If it was increasing, decreasing, if it had equilibrium points, and all sorts of things like that. Then yesterday, if you did the homework, we did slope fields. We looked at a picture of all the slopes of the tangent lines on a grid. Remember? Remember what that x plus y equals, dy dx equals x plus y. Okay, well, this is another way to do it. We're actually going to draw a picture of a particular solution without solving the differential equation. So let's write the equation of the tangent line. This is linearization. It's the very beginning of Taylor polynomials. So it's y minus y0 equals my derivative at x0, f prime of x0, times x minus x0. So I can travel along the tangent line. If I go a little tiny distance, like to here, I'm not going to be on the function, but I'm pretty darn close, provided I don't travel very far. This distance. Let's call that h, which is a step size. Might not be very good. The smaller your step size, the better you get. So if I solve for y, and let's call that y1, I want to find this point, which is x1, y1. Sorry. So y1 is equal to y0, where you started, plus the derivative at x0, and it might be a function of x and y, times, and then it's x1 minus x0. That gives me my new y coordinate. I'm not on the curve anymore. But if I make my step size really tiny, so if I only go over here a little bit, I'm pretty darn close. Guess what we do to find the next one? This is an iterative process. Well, my next coordinate is going to be at x2, y2. So what I'm going to do is find the slope, now carefully listen to this, of the tangent line of the function. So I'm looking at this slope right there. And what I'm going to do is take the point on the tangent line and write a new tangent line so it's parallel to that one. And I'm going to go over a little distance, and I'm going to go up a little bit. And I'm still not going to be on the function. But as long as my step size is little, I'm still pretty darn close to what the actual curve might look like. I'm not finding the actual curve. I'm just looking at an estimate. So if I write the equation of this line, it's y2 minus y1 is equal to the derivative now at x1. Okay, it's the next point. Well, it's actually the derivative here, which is right there on the original curve, and then it's x2 minus x1. And so if I solve for y2, it's equal to y1 plus the derivative at x1 of the original function times x2 minus x1. We are going to call this the step size. That's h. And this could be the derivative. It could be a function of x and y. Is that right, Justin? Did I write that correctly?
Yeah, I think so.
Okay, because it's been a while since I've done multivariable. So the formula is my new y value, call it n plus 1, is the old one, the previous one, plus the derivative at x and y n, the nth one, the one before it, times h. Now I couldn't remember the formula this morning, and I just decided to derive it again. It's a particular solution. So you actually see a picture. And we have Euler on our calculators. Now, you may use a calculator in this section. However, I would suggest that you do the first two estimates by hand using a calculator to help you with calculations. But there's ways to do it right out with the program on the calculator because it's going to be a non-calculator question. We can look at some of those. Don't want to really do the one with the differential equations yet. I put a whole bunch together so I can bring it up. So we are going to start our graph of 0, 1. Let's see if I can put a little graph here. Whoops. Okay, I don't like that. I'm kind of one of my neat moods today, so it's got to be right. And there. So we're going to start at 0, 1 right here. And I really don't know where the function is, but I'm going to find the next point on the tangent line to my function. So I don't know. It looks like this, something like that. And I'm going to take the tangent line and just create a step size. What did I want to make it at? 0.5 at a half. So I'm going to go over on the tangent line 1/2. So this is at 0.5. Then I'm going to go up here, calculate the slope of the tangent line there, but I'm not on that line, unfortunately. I'm still over here. So I'm going to be off a little bit. So I really recommend you do the first couple of problems in the homework because I actually have you draw those. Don't write in your book, though. Somebody probably already has. So where am I starting? I'm starting at 0, 1. Now my dy dx was x plus y. So I'm going to calculate the slope of the tangent line there. What is the slope there? Nicole? What's the slope there? This is brand new. You've not seen this. That's 1. So my new y value, the problem is you're going to have to make sure you stop at the right time. My next y coordinate is going to be my first, where I started, which is 1, plus my slope, which is 1, and my step size, this is h. How big was that? 0.5. So where is my new y coordinate going to be? I'm going to add that up. 1 plus 1 point. So it's 1.5. So here's my first point. I'm going to go over 0.5. And it's obviously not scaled the same. And here would be 2. Make that 1, 2. So 1.5 would be right there. And I'm going to draw that little segment. Now, I don't know where the curve is. I know it's pretty close. But now I'm going to start there. So my ordered pair after one step is 0.5 on the x's, 1.5 on the y's. We're going to do this a couple times, yes. Because they told me that. They gave us a step size of 0.5. Okay, so now the n is just how many iterations. Where are we starting on the x's now? I'm over here. We're at where? 0.5. Where's the next x value going to be? 1. X. Right? And the next one will be 1.5, etc. But they're only going to have you do 2 iterations because you're not allowed a calculator. Okay, and so what's my y value at that point? 1.5. So that's an ordered pair. That's this point there. You've got to keep track. Now, what's my slope there? Remember, the slope was x plus y. So that's 2. And to find my next y value, I will start with where I was, which is 1.5, and add in my slope. What's my slope? 2. And my step size is 0.5, or a half. So that's going to be 1.5. What's half of 2? So it's 2.5. So there's your ordered pair. They only ask you for 2 approximations. You stop here. Because where am I going to be? Where's my x value going to be here now? It's 1 and 2.5. So really, you stop right in here. I know the AP people are saying you shouldn't really use a table of values, but I really find that that's easiest for me to grade, and it's easiest for us to keep track. Yes. Their rubric will not have the chart. I write it up for myself. Okay, so I'm going to go over to 1, and I'm at 2.5, which is up here, so you can see what's happening. Let's just do one more iteration. I'm put it in a different color, though, because usually they only ask for 2 points. In fact, it said, in particular, I want to get, but I wanted to just get to 1 using 2 steps. 2 changes in x of the same size. Okay, so what's my slope here? You can see the numbers are starting to get nasty. This is 3.5, so I'm going to start with where I was. I'm at 2.5 plus the slope, 3.5, because it's x plus y, so I just add these. That's why I like the chart. It is. Yeah, it's not hard, it's new. And I even need a calculator now, honestly, to know where that is.
1.75.
It'll be up here someplace. If you want to bring the slope field back up, we can look at it. Yes? Yes? And that's Euler's method.
Wait, so what does that show?
That shows me a picture of a particular solution. Let's bring up this slope field, because I think I have my calculator up, so it would be easy. And is it still on my graph? No. So I'm going to quit. Oh, I probably took it out. Now, do you remember how to stop your calculator? You press on. That'll stop it. So y equals, that's because that's what I had in my other class, and I want x plus alpha y. I think it's this one. Okay. And then we're going to quit, and I'm going to clear my screen. Now, I wonder if it remembers that I was in a program. I'll find out. Press enter. Nope. Clear. Okay, so we go to program, and we have, oh, I don't have Euler on here, but you can do it Euler. It's pretty easy. Yeah. I used to have the whole thing where it did the slope field and then the Euler on it. It was really nice, but somehow that got deleted. Because people delete things on my calculators, and I don't know why, but they do. Okay, slope field. Y equals x plus y. I guess I don't need. That's your starting value. But hang on, let's look at the slope field first and see what we're doing. Alpha y. There we go. And I'm in a standard viewing window. And we are going to start at 0, 1. Now remember, mine is magnified. Right? I mean, here is 0, 1. It's right there. And here is 1. So you see, this is, you got to crunch it in together, but you can see what it's going to do. It's going to do this. Could I have step sizes going backwards, Justin?
Yes.
Yes, and they've done that. By the way, you've got the point on the Euler problem, even if you went the wrong direction. It was worth 2 points, but you got half credit. So it would look something like this. That's what the particular solution would look like. So on your Euler program that for some reason I don't know, and I might be able to get it onto my computer. I think they fixed it. So I'm going to bring up program, Euler, which I had the other one. Okay, what was our initial condition? It was 0, and the y was 1. Then I asked for my final x. I want to stop at 1, because that's all I'd asked for in this problem. And what's dx? That's my step size. It's 0.5, right? Oops, go to. Where's the problem?
What did you do it next one?
Did yours work? Mine didn't.
What did you final x at?
1. I got an error. Weird. I don't know why theirs works. 0, 1. Let me make final x 2. See if that works. No. So I may have to get your program. Something's happened to mine. And I've transferred my program onto yours. Oh, jeez, look at all my goofy pictures.
Your pups.
Yeah, it's my family. It's the only family I have left.
Hey.
Okay, I'll have to get their program and then I can give it to you. I don't know what the problem is. I'm sorry. Okay, let's do it again, but let's do smaller step sizes, because you can check it with your Euler program. You could do it with your calculator as we do this. We're going to do a step size of 0.1.
Don't have to like look up. How does it know what function to do first?
Because I asked you for that. Oh, you have to put it into y equals.
Into like y1?
Yes.
So what would you put in?
But mine's still failing. I don't know why.
What function do you put in?
X plus y.
In y equals?
Remember, this was dy dx. Euler.
I don't have this one.
X plus y. And there should be an Euler. If there's not, there's a TNS on the Euler.
Yeah, it doesn't work when you have it in there.
I don't know what the problem is. It's the y, but I'm not sure. Okay, I'll have to look at that. So we're going to start at 0, 1 again. And now we're going to have a step size of 0.1. What's our slope here? 1. It's the same problem, but we're going to make a smaller step size.
I don't know why these are there.
Oh, we could start anywhere.
Oh.
It was just, they'll tell you, they'll give you the starting value. So my y value is at 1 plus the slope of 1, and it's times 0.1. Now, there's a way to do this without the Euler program, and I didn't practice. So that's 1.1. So what's my new ordered pair? What's the next x value going to be? 0.1. And then this is 1.1. I'm trying to figure out a way to put this nice and neatly into, it's possible, I have to think about it, put it into a stat plot. You could plot it. Okay, so what's dy dx? 1.2. So we're leaving off at 1.1. The slope is 1.2, and the step size is still 0.1. Well, we can do this. It's 1.1. What's 1.1 times 1.2? Remember when you multiply decimals? You multiply the 1 and the 12, which gives you 12, and then you count back 2. So that gives you 1.22. And they'll never ask you to do more than 2 of these. So maybe 3 if the numbers are easy. So then you would come back. What's this x value that's at 1.22? It's 0.2. Usually you'll stop there. And then when you add this, you get 1.42. And so we are going to start with what we left off at, 1.22 plus my slope, 1.42 times 0.1. So it's 1.22 plus 0.142. So it's 1.362, et cetera, et cetera. You should get a better approximation if you graph it. Now you're making the steps really small. It's more accurate. No, we haven't done Euler. So you start at 0, 1, you're going to go over a tenth, and you're going to be up at...
The concept of steps, though, being small centimeters.
Yeah, well, we talked about that. There's 0.2, 1.36, so you're going to actually see a better picture like that. It'll be smoother, and especially when you look inside in the book at some of the ones that they did. Now, I have a nice pretty picture. Now, can I do this? Let me see if I can remember. Are you willing to let me try to do this on my home screen without Euler? Because there is a way to do it. Okay, let me look at my notes. I thought I had it written down. Yeah. Yeah, I don't know why my program's not working. Okay, so I want 1 plus 1. Oh, wait, maybe I want to do this. 0 store in for x, 1 store in for alpha y. Whoops. Yeah, I don't think that'll work. 0 store for x, 1 store alpha y. I can put the clock up on my screen. Okay, I think I got it. You guys should take some programming classes.
It's geometry.
Then you should write the program for this.
Don't you just use one set?
Okay, what I did was I put in my initial condition. I put 0 in for x, 1 in for y. And then I took the y value, which is 1. And then y1 was x plus y, so it should have added those, which is 1 times 0.1. I get 1.1.
So that's
Now,
using the program?
that is a lot using the program. So it's just an iteration. I think I can just press enter. And I get the next one. Uh-oh, why am I off a little bit? Yes. Because it's on my calendar. Okay, I've got a mistake someplace, but you can see how you can iterate on this and pick up the things. But there's something wrong. Okay, guys? So you want some problems to try?
Yeah.
Okay, let me find them. Let's see. I know I made them. This one? Where did I make them? I swear I made them. Oh, I know they're not in here. That's a nice little one. There you go. Let's do that one. Okay. This is the double-double problem. Yeah, I would like you to try it first. Okay, we have not talked about how to do Part C in this class yet. It is essential you know how to do Part C. Okay, Marcus?
Yep, got it.
That's solving a differential equation. This is the AB part, which is 5 points. Because remember, 60% of the exam is AB. And this is the BC part worth 4 points. Let's see what you do with this. The reason why I say that is I graded this problem.
This A or B, I don't mind. No,
It's 2010. It's a BC problem.
but we have
Regular. I didn't run the B problems off for you. I did run off the polars and vectors in the B's. Now, let me see if I can find out what's wrong with my calculator. And see if I can figure out how to do this. No. Yeah, I'm going to let you. Okay, so it says there's your differential equation. dy dx is 1 minus y. And it says we're going to start at 1, 0. So I'm going to put my little chart here. This is n, this is x, y. I like to write down my slope. And then to find my new y, oh, they call it L, plus dy dx times my step size. That's the plan. You don't have to go very far. So we are at, for the first 0 iteration, we are at 1, 0. What's the slope there? 1 minus y, which is, what's the slope? 1. Now, we are starting there, and where are we trying to go? We're trying to find x equal to 0. By the way, you got to have credit for this if you went the wrong direction. So what's the step size? 2. Now, we're going to go from 1 to 0, and we're divided into 2 equal steps. So step is 0.5, but it's what? It's negative. Did you not use a negative?
Wait, how do you know you're going from 1 to 0?
Because you start at 1, and we want to end at 0. So if you do the x's first, maybe that will help. I don't have to have the ends. But I want 0.5 for the next x, and for the next x, I want to be 0. Right? That makes sense now? And so my new y value is my old y value plus the slope. Oops, the old y value is 0. Look at your chart correctly. Sorry. It's 0 plus 1 times a negative 1/2. So it's negative 0.5. Right. Well, we can check it. So what's dy dx? It's 1 minus y. So it's, no, it's 1 minus 0.5. Negative 5, I'm sorry. So it's 1.5. So it's negative 0.5 plus, the slope is 1.5 times a negative 1/2.
Negative 1.25.
So it's negative 1/2. What's this going to give me? Half of negative 0.75. I could rather just keep that at 0.5. So it's negative 1.25. If you go beyond what they ask, you will lose points. Sorry.
Yes, that's
That's
just
right.
way
Yeah,
too much
I did
work.
way too much work than last year.
Didn't do this last year.
No, I mean, in general, on everything, I did way too much work, so they took off so many points probably for me.
Yes, you do. If you say too much, you can lose points. No, that's it. You get a point for realizing how to do Euler's method correctly, even if you have the wrong step size. So you got a point for that. Then you get a point for your answer. Is that what I got? Oh, that's what I got. Good. Good. Okay, so then when this gets scored on your exam, this goes in the BC score. Now, question B is a B. Now, when you look at, you guys, shh, when you look at these and you see this, which you know is BC, and you look at the last one, solving differential equations, an AB topic, you know it's the double bubble, which tells you that B has to be a BC topic. Has to be. So how do you find that limit? Okay, I want you to write it up and we'll grade you. I'm going to grade you on this. Yes, I'm going to show you how it was graded so you know what to do.
Oh, that.
It's right there, negative 5/4.
You're asking what the y value is at 0?
Yes. Put it backwards.
Say that.
It says it underneath my little recorder there. F is 0. Make sure you read the problem. What's the very first thing that you should do? Now, why is this not working? Okay, Justin is going to do this problem. You guys pay attention because I want you to get your points. Oh, it doesn't matter if you didn't get it right. You have to show the work correctly.
No, that's proper word,
The
man.
work's in my head.
No. If you just write down 1/3, you get 0 out of 2.
It's like physics if you get the right answer. They don't care what work you have.
Not in math.
No, they don't, Vader. If you get the right answer, you get full credit. It doesn't matter. All
And even the scoring guidelines are not complete.
Trying to get all points. No, not at all. Vader, guess what?
Well, I'm telling you, that's how they grade the calculus one. You have to have the work. He doesn't have to show that necessarily, but what he has to do is show the next step right there. If you don't do 0/0, you don't get that point.
I can do that. I do that all the time, don't I?
I should have done that. I just put Loki.
No, maybe you say L'Hopital, you don't get the point. And this is, and nothing's open for discussion. When we go and get briefed on these problems, no questions, no comments. Yeah, it is.
I think today's the day where we call out those freshmen that come in too early. We go, hey, bud, and you grab them by the shirt and you go, stay out of
You're
this
being
class.
recorded. Okay, now, I want to make sure this is clear, okay, you guys? You want to solve the difference? I thought we'd do it tomorrow.
Go speak for 2 hours. We go to Narnia.
Okay. What?
It's up here in earlier
F problem 1 was given to us as 0. Somewhere in the problem.
That's kind of one of the points.
Oh,
That's what you want to do. But how we don't have a prime?
Right here. F of 1 is 1. You over x 1 is 1.
You really should have put the F prime.
it's the limit of F of 1. It's 0.
I did.
I know that, but
You
how do we know
should have wrote that.
No, where are we given?
1 minus y. And then you should have plugged in.
Oh, F prime 1. Substituting 0.
It's 0. You're not doing it.
That's F prime.
What? Isn't that
dy dx is F prime. It does. There is no x value. It's 1 minus y. Y is 0, so it's 1.
okay?
That'll be 1/3, so it's 1 1/3.
I want to show you something else about this, though. Okay. Okay, guys, if you didn't write the 0/0, you didn't get the first point. A lot of students got nothing on this. Then the next thing is he does L'Hopital. You don't have to write the L for L'Hopital. It wouldn't hurt. And so he goes f prime of x, which is f prime of 1. How do you get the value for f prime of 1? You go back to dy dx, and you substitute in the y value when x is 1, which turns out to be 0. So that's why that's 1. That wasn't the problem. This is what I saw. Oh, probably 50% of the time. I graded this one.
Only points that I've got.
You would get all of them.
How do you get all?
Okay, but this is what we saw so many times. Okay, now, you could get more points.
How do you even get that plus one?
Because was it minus 1 or plus 1? Oh, minus 1 then. They just didn't take the derivative of that. You can get some points. Let's say you don't put the 0 over 0, so you've lost that point already. And you got 1 point if you said clearly that the derivative with respect to x of x cubed minus 1 is equal to 3x squared minus 1. You didn't get the point for this piece, but you did get your answer point of 1/2, as long as you declare that you're taking the derivative. Oh, we can do it on here. That's the tricky part. So when you do a derivative, no, let's put it on here. What? You just have to say this. Obviously, this is wrong, but we continue reading. We continue reading, so you can get some more points. You have to be really clear. Well, I haven't taught the last part yet. Not this year. Let's just do it on the scoreboard. Do a new page? I'm going to turn this recording off, though.
Give us this. Is it
Mhm.